This is the lecture video for section 5.5. This is video 3. Now we're going to show in one example on how to use double angle formula to find trig function values. So again, the 5 double angle formulas, 3 of them is for cosine of 2a. Cosine of 2a equals to cosine square of a minus sine square of a, or equal to 1 minus 2 times sine square of a, or equal to 2 copies of cosine square of a minus 1. Sine 2a equals to 2 copies of sine of a multiplied by cosine of a. Tangent of 2a equal to 2 times tangent of a, or over 1 minus tangent square of a. So the example we have is we want to find the values of 6 trig functions, given that cosine of 2 theta equal to negative 12 over 13. And then we know that theta is going to be between 180 to 270 degree. So this one is different than the previous example. Since we have cosine of 2 theta, we cannot really using the Pythagorean identities. The only formula we can use is the trig formula. The double angle formula. So for the double angle formula, we have 3 options to choose from. So still I'm doing the scratch works right now. Cosine of 2 theta can equals to cosine squared of theta minus sine squared of theta. Can also equals to 1 minus 2 copies of sine squared theta, or 2 copies of cosine squared minus 1. So since we're going to looking at the 6 trig values itself, it is a little bit harder to finding both sine and cosine at the same time. So we're not going to use the first option. The second two, actually we're going to use both. One to find sine theta, the other one we're going to use to find the cosine theta. And then once we have those two, we can find the tangent theta using the quotient identity. And then the reciprocal identity to find the cosecant, secant, and cotangent. Okay, so that's the plan. So now we're going to start working it. So step 1, I'm going to find sine theta. So cosine of 2 theta will equals to 1 minus 2 copies of sine squared theta. So this is the formula we're going to use. Cosine of 2 theta from the problem we know is negative 12 over 13. So 1 minus 2 copies of sine squared theta. Then negative 2 sine square of theta will equal to negative 12, 13 minus 1, which is negative 25 over 13. Divided by negative 1, divided by 2, so 25 over 13 divided by 2, which is the same as multiply by its reciprocal. So we end up with 25 over 26. But we're not finished yet. Before I move the screen, just to point it out that theta between 180 to 270, that means theta is in quadrant 3. Both sine and cosine are negative. Tangent is positive. Okay, so I'm going to continue. Taking the square root out, sine of theta, as I mentioned before, is going to be negative 5 over square root of 26. Rationalize the denominator, 5 square root 26 over 26. we're going to apply the same thing, but this time we're going to find cosine of theta. So cosine of 2 theta equals to 2 copies of cosine squared theta minus 1. Negative 12 over 13 equal to 2 times cosine squared theta minus 1. Adding 1 on both sides. So we end up with 2 copies of cosine squared theta and 1 over 13. And then cos divided by 2, we got 1 over 26. So cosine of theta will equal to negative 1 over square root 26. Rationalize the denominator, which is square root of 26 over 26. Negative square root of 26 over 26. So now we have the sine of theta, the cosine of theta. I'm going to do step 3. Since I have the sine of theta, so I'm going to just do cosecant of theta will equals to negative my software have a problem. So cosecant of theta will equals to 1 over sine. So just to point it out, the formula I'm actually, or the step I'm actually follow directly by, not the rationalized one, is the pre-rationalized one. So I got cosecant of theta equals to negative square root 26 over 5. Step 4, I have the cosine. So secant is equals to square root of 26 negative. Still the same thing. My secant is actually I'm reflipping, or I'm finding the reciprocal of the pre-rationalized one. Step 5, I'm going to find the tangent of theta using sine of theta over cosine of theta. Sine of theta is, by the way, I do not want to have more complex fractions, so I'm going to change the division into a fraction sign into a division sign. So sine of theta is negative 5 over square root 26. I'm using the pre-rationalized version. Cosine of theta is negative 1 over square root 26, still the pre-rationalized version. Divided by fraction is the same as multiply by its reciprocal. Square root 26, negative 1. So simplify them, I got 5. So the reason for me to using the pre-rationalized version is more easier to working with it's more clear to see what do I have in commons, how can I simplify them, versus the rationalized denominator version. I can see it, but probably I need to simplify it after I find it. Okay, so the last step, step 6, is my cotangent. Cotangent is 1 over tangent, so it's just 1 over 5. So as a conclusion, the answers are sine of theta equals to negative 5 square root 26 over 26. Cosine of theta equals to negative square root 26 over 26. Cosecant of theta equals to negative square root 26 over 5. Secant of theta equal to negative square root 26. Tangent of theta equal to 5. Cotangent of theta equals to 1/5. By the way, just another kind of quick note. For square root 26, even for the previous one, I believe it's square root 21. I do quote unquote simplified it, but because of 26 is equal to 2 times 13, 21 is 3 times 7. There's nothing I can continuously to simplify, so I didn't do anything to simplify. square root of 26 because there's nothing to simplify it. However, if I have square root of 24, for example, which is 4 times 6 equal to 24. So I have to simplify square root of 24 into 2 times square root of 6. So when something is simplifiable, you have to simplify radical numbers. If it's or those two examples, it just happened that those two numbers, square root of 21 or square root of 26, they are not able to simplify it.